We're looking at recommended measuring systems in the first part of the webinar today. We're going to start by looking at the Isotech Mini-K. We've got a new brochure, and this brochure will be cross-referenced to sample certificates, and it's going to guide towards the best solutions. Not the only solutions, we're always here to give advice, but we want to signpost people towards systems that we know work well, and we really want to make it easy. The Mini-K has proven to be a great success. We're strong on performance, price and flexibility. And last year we ran a webinar on the Mini-K looking at that in detail. That can still be accessed, so if you missed that or you'd like to revisit it, if you let me know, I can send you a link to the recording of the Mini-K webinar that we did last year. But today we're focusing on the measuring systems and wanting to make it easy for the client to understand what performance can be obtained for the complete measuring chain, the Mini-K and thermometer together. So the Mini-K, the initial accuracy is 0.005 degrees C, 0.007 over the year. And for thermocouples, our voltage accuracy is 2 or 4 microvolts. So for a type R thermocouple, that equates to about 0.15 per degree at 1000 degrees. For type N thermocouple with a higher output, it's about 0.05. So it's easy to understand the accuracy of the instrument, but how does that change when we have thermometers to it? What accuracy when used with Isotech semi-standard platinum resistance thermometers? Well, our semi-standards are very stable, and we can calibrate them to much better uncertainties than the IEC 751 tolerances. Let's see what they are. So this is from the standard for industrial PRTs, and it's not that great. At 100 degrees C, it's about 0.27 for the tightest class. If you go into 600 degrees, the standard only allows class B to go to that temperature, and its tolerance is in the tolerances, and it's 3.3 degrees. So that's not great for us, and it's pointless to use a Mini-K if the PRTs aren't calibrated, because we'll have the high accuracy for the Mini-K, sure, but the tolerances on the PRTs will be so poor that we're not getting a good measurement. So our probes are better than the tightest tolerances from IEC 751, but they still need calibration. So PRTs for use of the Mini-K need calibration. So how do we calibrate them? Well, we could use IEC 751. That's the standard. That's the method used in the standard for calendar van Joosten CVD specified in IEC 751. And this is the equation here. Let me just put my pointer on. This is the equation here in the standard, and the standard gives us. Sorry, where's that echo? It's me. The standard gives us the tolerances, and that's how it works. But what we can do, we can measure the PRT at different temperatures. We can calculate unique coefficients to fit the temperature resistance curve for a particular probe, and then we can program those coefficients into the Mini-K. But at Isotech, we don't want to do that. Rather than using IEC 751, we prefer to use the SBRT equations from the ITS 90. So these ITS 90 equations do a better job of the curve fit, and that's what we're going to do with the Mini-K and our semi-standard PRTs. These equations and how it all works, if you search online for Guide to Realization of the ITS 90 and BIPM, you'll go straight to that document. So this is how we do it. We will determine the resistance of the thermometer at a number of calibration points. And from there, we can calculate the ITS 90 coefficients to measure the resistance and to program that data into the Mini-K. So step one, in a fixed point cell or a liquid bath, we would calibrate the semi-standard probe. From that calibration, we can get the ITS90 coefficients, and then we can program those ITS90 coefficients into the milli-K, and then we repeat the calibration with the semi-standard probe connected to the milli-K, and you get a system calibration certificate. So that's what we're doing. So what's the accuracy? Well, the uncertainty assigned to the calibration of the semi-standard is dictated by the hysteresis, the repeatability, the stability of the probe, and the immersion effects. But the typical uncertainties for probes are on the order of 0.01 to 0.05, 10 milli-K at 0 degrees C, 50 milli-K at 660. Now note our calibration certificates, the ISO 17025, so they were specifying uncertainty rather than an accuracy. But once we've calibrated our systems, the error of the semi-standard PRT will always be smaller than the uncertainty. So we can see it as the same. The uncertainty we quote is the uncertainty, but any offset or errors or accuracy will be within that uncertainty. So here's a sample certificate. If we look at a certificate for a probe calibrated to 660 degrees, we'll have the milli-K indicated values, and then we'll have the uncertainty of the measurement. And our system certificates will also show the coefficients that we programmed into the milli-K for that calibration. And you can see that this is a typical probe, and it's within a few millikelvin, a few thousandths of a degree C between the measured temperature and the indicated value, well within the uncertainty. So we want to make life easy for people because it can be quite complicated figuring out the ranges. So we've made this new guide, and we're recommending the most popular PRTs and the calibration ranges. So we've got a flow diagram, and that will help us identify which probe we might want to use. And then as we determine which probe, we put in here the calibration points and the uncertainties, so the customer can see what they can expect over different ranges. And we've also, which I'll be sending to you when we finish, got a whole range of sample calibration certificates cross-referenced, so we can actually give the customer, you can share these, saying this is a typical calibration certificate for this probe. Other options exist. If someone wants to have a particular range, yes, let's talk about that. But let's start by signposting people towards systems that we know work well. And then when we're talking to customers, the question we always get is, well, how many calibration points do I need? And the client might say, I want 0 degrees, 100, 200, 300, 400, 5, 6, 7 points. And we could do that, but it would be unnecessary, because the ITS90 sub-range over this range is 0.01, the water triple point, to the freezing point of aluminium at 660. And we just need 4 data points. So to produce those ITS90 coefficients, we need 4 data points. And we can assume that the linearity, we can assume the uncertainty will be linear between these 4 points. So we can say to the customer, you might need to cover that range, but really, this is a metrology instrument, high quality instrument, high quality resistance thermometer. You can follow the ITS90, and the ITS90 tells us we need just 4 points. And to make life easy, we've got a chart here with the different temperature ranges, which points we calibrate at, and which coefficients that we get. In Europe, we tend to just call them A, B, C, D, positive and negative. In the US, it's more commonly to call them, A6, B6, C6. It's the same thing. It's just a terminology and how we refer to the coefficients. But we've got the reference chart. We've got some nice giveaways. So we've got these giveaway reference cards, which we can give to customers, which show the ITS90 sub-ranges. And in our new brochure on the inside front cover, we've got, again, a chart. And we've popped some examples in there as well, explaining how to use the chart, because some people, if they're not familiar with it, can struggle a little. So that's what we're saying for PRTs. But what about thermocouples? Well, below 660 degrees, we're always going to recommend using a PRT. These are expensive instruments. People are choosing them to make good measurements with low uncertainties. So we don't really want to be talking about type K, even type N thermocouples. It can be done, but we want to signpost people to get the best measurements. But above 660 degrees, we would recommend using a noble metal thermocouple. You can use a HT SPRT, a high temperature SPRT to 1000 degrees, 962, but you wouldn't really do that with a midi-K. We'll come on to SPRTs later. So a noble metal thermocouple is a good choice, and we would recommend in general the Isotech 9351488. This is a type R thermocouple, but the wire all the way from the plug to the tip of the thermocouple is platinum wire, the best wire commercially available, no extension cable. And so that's best practice. So that's where we'd recommend people. So with thermocouple calibration, we rely on the voltage to temperature conversion from IEC 60584, which is the standard, and then we apply a correction for the error. Now with a type R thermocouple, that error is small and it's easy to predict with a polynomial equation. So this is what we do. We would calibrate it at just a few points. 4 points is sufficient. If you're only going to 1100 degrees C maximum, then we'd recommend calibrating it to maximum of 1100. If you need to go to 1300, then you need to calibrate it to the higher range. But note how the uncertainty increases at 1300. So the errors on the thermocouples are small and easy to predict. We don't need so many calibration points. And again, our new brochure will signpost people to these two ranges. So what happens is on the calibration certificates, we'll have the measured temperature. We'll have the measured temperature and then the measured EMF. Then we'll look at the error, the difference between the two. And then we've got this equation here, which fits the error curve. So we determine the velocity of the thermocouple to the number of calibration points. And from there, we can calculate the coefficients to fit the error curve. And like with the PRTs, we program those coefficients into the midi-K. So this is the midi-K screen where we've taken the coefficients on the certificate and put it into the midi-K. And then again, same as with the PRTs, we repeat that calibration and report the midi-K display value against the temperature on the calibration certificate. So what we've shown so far is how we can calibrate the thermometers and the midi-K together to get world-leading accuracies and the legal traceability of UCAS ISO IEC 17025. But there's some subtle points that I want to bring out, because in addition to the measuring chain calibration, we need to think about some further points. So the midi-K for the instrument alone includes a traceable calibration certificate. So when you buy the midi-K with or without a probe, it always includes a traceable certificate, but it's not ISO 17025, because most people don't need that, but some will. So it's a chargeable option. If you want ISO 17025 for the electrical simulation, where we inject ohms and voltages to calibrate the PT100 and thermocouple ranges, then that's an additional cost. So why might we need that? Well, here's one example. The midi-K is being used to measure test probes as well as the references. So here's what we've been discussing, the system calibration of the thermometer and the midi-K together, and this is ISO 17025. But if the customer connects their probe, which has not been to our laboratory, to the midi-K, and measures the ohms or the voltage from the sensor, then it'll only have a traceable calibration certificate unless you've also chosen the UCAS option. So without UCAS calibration, the midi-K, the uncertainty of measurement of the customer's probe relies on the traceable calibration certificate. Now, for some clients, that'll be fine and sufficient, But for others, perhaps those working in ISO 17025 laboratories, it won't be. They will also need ISO 17025 for this measurement. Not a problem. It's just something that you need to specify the customer needs to purchase when they go for the system. And then there's one other example where it can be a good idea to have two certificates. So here I've got one certificate for the MIDI-K, and I've got other certificates for the reference probes. So suppose the client's got many calibrated probes, that's different manufacturers' probes calibrated at different times. But if they've got several probes, it's not convenient necessarily having it always calibrated, the probe and the MIDI-K together. So it can be beneficial when you've got a lot of standard probes, so the calibration certificate for each probe, and then another calibration certificate for the MIDI-K. There's some drawback, but it also can be beneficial when you've got a lot of probes. So those are really the two main examples where we would recommend to the clients that they choose UCAS for the MIDI-K either instead of or as well as the system calibration. Some more commonly asked questions. Well, we have a MIDI scanner. We can connect to a MIDI scanner, and now we can measure 8, 16, 24, 32 channels. Does that need to be calibrated? Well, the MIDI scanner doesn't measure itself, and it doesn't add to the uncertainty. So generally, we wouldn't recommend calibration, but for confidence, you could check it. You can move the sensor between different channels to make sure you get the same measurement. So maybe you put the PRT in an ice flask, put it on channel 1, and then on the other channels to see you get the same measurement. So there's some evidence and some confidence. But if you want the assurance of calibration, we can do that. Of course, each channel you calibrate adds to the cost. So we would generally recommend calibrating the first and the last channel. Now, there is a temperature sensor inside the MIDI scanner. This is where we connect the thermocouples here. So there's a temperature sensor in here to measure the cold junction temperature. So that might be a good idea to have the MIDI scanner calibrated annually, but that's only if you're using thermocouples and only if you're using internal cold junction and thermocouples. But if you're using PRTs or thermocouples with external junction, that temperature sensor is not in use. We've got a lot more about the MIDI-K. I mentioned at the beginning, we've got a webinar. Some of you were present for that webinar on the MIDI-K last year. Just ask if you'd like to access it. MIDI-K is really a nice instrument to automate, so you can do automatic calibration. And we've got a presentation from the last seminar that we did before COVID in 2018, and I'll be sharing the links to that. And if you want the webinar, though, you just need to ask me for a link to the recording. Okay, so we're going to move on to look at the SPRTs and Micro-K next. It's a good time to ask any questions. If anyone's got any questions, please feel free to type into the chat. If not, I'll move on. Okay, there'll be time again for questions later. But what I've covered so far is the MIDI-K PRT system calibration. I've shown you the new product guide, which we'll be sending to you, and some sample certificates. But in the next part,